Hello everyone. Today we are starting the module 2, which is related to the different electrical components. And the first chapter in this module 2 is chapter 2.1, which is related to switch and sockets. So let us start this first chapter. So the first thing is switches. We know in our houses, we've already seen the switches. So the primary function of switches is to control the flow of electrical energy, like giving the user control on switch on and switch off. Now these switches are categorized based on their ampere ratings, that is how much current they can break or make, and how they are used, their functionality. So in our houses, we generally used one-way switches. These are generally used for on-off purposes. Two-way switch, again this is used for on-off, but a special feature that it can be controlled from two different locations. Okay, and then we have bell push switches. Okay, which we use for at a bell at our door. Now the question arises, a basic question: how does a two-way switch work? So two-way switch is nothing but a three-terminal device. Okay, it has three different terminals. Okay, L1, L2, neutral. As you can see here in this diagram also, this is the staircase. If some person is standing here and he want to switch off this particular light, so what will happen if uh, if my terminal it is like this? Okay, it can be by this switch, it can be either at this position, it can be either connected to this, or it can be connected to this. Now if here in this diagram also we can see this is phase and neutral, so my circuit will complete when my phase and neutral are connected. Okay, so in this we can see that this phase starting from here, coming from here, is again connected to this bulb, and then it is coming back to neutral. So this is how my circuit is currently completed. So my this light is currently on. Now if some person have come down and forgot to switch turn off this light, or in the staircase sometimes we want that there should be a adequate light to work. So sometimes we want that after I reach the bottom, I want to control this switch. So how we can control this? If I toggle this switch here, then this terminal will shift from here to here. Now as you can see, the circuit has been broken. Okay, from neutral to phase the circuit is broken, so my this bulb will become off. So this is how a two-way switch works. The next part of this first chapter is socket. So socket is nothing but it is an outlet where the power is extracted using a plug. So this is a plug and this is the socket. In every socket there will be at least one live and one neutral. They can be more terminals or the holes, but they will be again dependent on the application to application. In our household we generally use this 3-pin, or we can use a 2-pin if you have seen it like this, which is mostly used in the IC based electrification. Now a general question arises in this 3-pin socket plug also, or in this socket also, You can see why in the 3-pin socket the top pin is longer and thicker. You can see this is longer and this is also thicker also in comparison to these two. Why this happen? This happens because this terminal or this top is basically earth. So what happens for every appliance to be connected to the to live part or to the to the to extract the power, it is from safety point of view it is required that its earth terminal first connected. This is why it is longer. So the reason for being longer of this is because make the first making should be of earth, so that if any leakage is in appliance or the device, it again come back to the earth, or it goes complete circuit to earth, so that the person do not get affected or do not get a shock. Now the reason for its thickness is because if there is any leakage, okay, due to any fault, then the current will be huge. Okay, current will be huge, very huge current will be there. So we want from engineering point of view that it should be able to handle that large current. This is why it is thick, to have large current, which I'm representing I, okay, capacity, large current to handle the large current capacity, it is a thick. So this is why this plug or and the sockets are designed. Now there are different type of sockets, okay, same as the switches we have seen earlier. There are 2-pin sockets, okay. There are this 3-pin. This is the 3-pin. 3-pin means there are 3 pins, 1, 2 and 3 holes. So it's just 3 pins, 6 by 16 ampere. This is again this type of is generally used in IC standards, okay. Then there is a 3-pin 16 ampere socket. This can be used for 16 also, for for geyser or microwave. For loads which require more than 16 ampere, there is this metal plate, okay, with MCB as a switch. Why MCB? Because MCB has a higher current breaking capacity. And why this happens, we will learn this in the other modules. Now one more question I have taken here, that where do we use this 2-pin 6 ampere and where do we use 3-pin 6 ampere? Okay, here also I have mentioned 2-pin, it is, if it is a 6 ampere, then where do we use it? So the 3-pin 6 ampere socket is used where there is the body of the appliance or device body is such that it has any metallic part in it, such that there is a possibility that the shock can travel to the person who is using it, okay. And the insulation is such that there are exposed current carrying part exposed. What does that mean? In the case of fridge or refrigerator, we have seen that it has a metallic body. And second thing, in its at its power supply, the power supply is such that there are few exposed parts, such that they can be connected to the my body of my fridge, and body is metallic also. So for this fridge we will be using a 3-pin 6 ampere. If my I am assuming my fridge is taking 6 ampere of current or less than that. It should be, if it is taking 5 ampere, then for fridge I'll be using. But for the devices, like like my phone charger, okay, phone charger has insulation and its body is such that there is no metallic part and there is no chance of shock to the person who is using it. So phone charging will use 6 ampere 2 pin socket. Okay, so we have understood what are the different sockets and where they are used. Okay. Now, as you have seen before going to completion of this particular chapter, one more thing I would like to tell. These are generally based on IEC standard. Okay, for NEC standard, we will be looking about their introduction about them in the near future modules. Okay, so these are related to international standards which are mostly used internationally, but for the IEC NEC, according to NEC, they mostly use NEMA, NEMA standard or NEMA based sockets and switches like 515 or 620. We'll be learning about them in detail in the later modules. So so for time being, I'm basically completing this particular chapter of the module 2. So thank you for your time and attention, and for the next chapter in the same module will be related to MCBs, which is miniature circuit breaker. What are these? The distribution board, and RCDs, which are residual current device. Okay, which are mostly RCCB in case of IC standard, and GFC are ground fault current interruption in my in the NEC standard. So thank you for your time and attention. Thank you very much.